Hello friends, welcome again. So today we are going to discuss API design. So up to this point, we discussed a lot of general topics, and going forward, like from next week, we are going to discuss very important building blocks. So if you're new, so it's a high-level design series. So now we are going to discuss API design. Okay, so be with me and subscribe this channel because we are going to discuss very important topics going forward. Let's get started. So API design. So I think you all know how to write API, right? Very simple, right? But the thing is how to design the best way, right? So we are going to discuss that part. What is a good API design? API design is not about code, right? Everyone knows, okay, at the rate rest controller and then get pepping slash expected, whatever, right? So writing code is very simple, but the thing is experience, right? You should have a good practice. So how we can achieve predictable, consistent, okay, readable, expandable, safe. Okay, so these artifacts should be considered in your API design when we are writing our endpoints. Just like as example, bad, create user, right? Instead of slash users with post, right? This is a good design. API should communicate, meaning without documentation. What does it mean? By reading names, right? It should be clear what we are going to do. Okay. API design principles. Resource oriented design. I'm going to say the very first part is we have to use nouns, not verbs. Okay, just like as users, accounts, transactions. Example: orders, 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 order ID, uh, put orders, order ID, delete orders, order ID. Okay, so they are the standard practice. Consistent naming convention. Use lowercase, hyphen, separated or plural nouns. Avoid mixing patterns, just like as get user by ID. Okay, like it doesn't make sense, right? User slash 123, it's automatically, tells 123 is the user's ID, right? So no need to mention all these things. This is also correct, like not bad, because usually we write these kind of names as well, get user details by ID, but still, this is the best practice. Just write user slash ID. That's it. Proper use of HTTP methods, just like as get, it should be for retrieve, post it for create, update, oh sorry, put full update, patch, partial update, delete, remove. Okay, so we have to do just like as for post, right? It should be used for create only, right? Not for retrieving or this kind of methods, right? Retrieve user doesn't make sense, right? Create user still good. Clear status. So use meaningful HTTP codes. 200, okay. 201 created, 400 bad request, 401 unauthorized, 403 forbidden, 404 not found, 409 conflict, 500 server. Don't always return 200. Okay, what does it means? You might return these, okay, right, but still don't always return 200. Okay, now design request and response model. So how your design should looks like. Simple. You can say user zip L name. So instead of writing this L name, F name, you have to write full name, first name, last name, zip code or like pin code, something like that. Okay. Second is response structure. So this was how your request looks like. This is how your response looks like. Status, success. data, whatever you want to include. Time spent or request ID. And say who requested. So point number one, status. Point number two, data. Point number three, time spent, stamp. Point number four, request ID. Who requested? Okay. So these four uh, fields should be there in your response: status, data, stamp, and request ID. Okay. Now pagination. Simple. Page is 1, limit is 20. User slash query param, page 1, limit 20. Okay. Response should look like whatever the details you are fetching, items, page 1, limit 20, total pages, total items. So every time during pagination, you have to follow this kind of practice. So this is a common, right? Not in only e-commerce. Suppose wherever we are fetching records, right? So always you have to use this pigeon like this: page, limit, and total pages, and item, total items, 200. Okay. Now error handling and documentation. Error response structure. How should our error response structure looks like? Status, error, message, whatever, code, whatever, details. Okay. So these are standard fields we have to include: status, message, code, okay, and detail, right? So it shouldn't be like, okay, just like as error, field email, message this. Okay, it should be like this. And documentation, a very popular Swagger. We use Swagger, right, for our documentation, or you can use Postman collection as well. But this is very common. This Swagger, this is very UI friendly as well. So always use documentation like Swagger and Postman or whatever you like, but still it should be there, right? Versioning and backward compatibility. So this is important, right? Suppose you have some changes in your API, right? Then you should put right this URL slash, it should be like v1 slash your users. Okay. Uh, If I say like this, your URL slash v2 for your next release slash whatever users. Okay. Is your first, second release. For another release, URL slash v3. Another release mean to say if you are making any sort of changes, users. Okay. So these kind of practice you have to use. Header versioning. Application slash vendor VND company V1 plus JSON. Okay. So something like that. You have to keep your versions, right? To suppose right now you are at this and you have made some changes, and again you are using the same v1, right? Then how come you go back, right? So whenever you're making changes, you should change your version as well, right? And to make your backward compatibility, right? So when to version, breaking changes, remove fields, whatever you're making it, right? So you have to use versioning. Security and rate limiting, authentication and authorization using Oath 2.0, important, JWT tokens, API keys. So all these are methods we generally use, right? So O2, API or tokens, right? Rate limited, very, very important to protect your APIs from abuse. You can use any type, just like as token bucket, fixed window, sliding window, right? Example 429, too many requests. What does it means? To limit your calls, right? You should use some methods. Means it use any method. Okay. So scalability, very, very important. Okay. So how to design your APIs to get it scaled, right? First of all, idem idempotency. Okay. Ensure safe retries. What it does means, suppose create user. Okay, just like as okay example, put user 1 to 3. So person is calling this put API again and again, again and again, again and again. Okay, or patch means full update or partial update, right? Patch slash valid slash top up again and again, again and again, again and again. Okay, two. So we have to take care of safe retries. A sync operation, long running task. So we always use a sync operation for long running tasks, just like as very, very important. We always use Kafka. Okay, why it is okay. So we always use Kafka for this kind of uh, async operations. Okay, not sure why the mark is getting off. Okay, so no issues. Then caching. So caching again very important. So we have to use uh, caching to make our system fast. Okay. So under caching, that is this is our general use. Okay. And CDN, this is our content delivery network. Suppose we are in Asia and we are making request to North America. It will be there will be some delay, right? So using CDNs, we can make it fast. I mean to say, we can use we can make a CDN at Asia only, and then we can get data from CDNs, like from our nearest endpoint. Endpoint, okay. That is CDN and HTTP caching. Then database query optimization. It's in our hand. Okay, how we are writing queries. Okay, just like as avoid n+1 queries, use filters. Okay, so these are very important. Idempotency, async operation, caching, database query optimization. So in that way, you can scale your application, um, meaning scale your API. So just a simple example: post slash user123, first name, last name, email, phone number. Succeeded 201 created. Status created is already this. Written these things. Okay. Payment API just like as payments slash ID status for patch, for get ID, for payment ID, these kind of things, right? Okay. So these are the high level API design practice which we have to follow. Okay. So this was a simple video and I thought, okay, no need to create a demo on this. So that's why I'm closing this video here. So going forward, I think disaster recovery and distributed tracing. So these are important. I will create a demo here as well. And for here, our main important topics will be start, might be from next week. So just subscribe this channel to be with me. And for now, thanks so much for watching this video. And bye for now.